I want to put new rubber boots on the drive shafts of my 94 quad bike. I've been out over Christmas having a blast around with the grandkids. Happy New Year to everybody.
Today I'm going to fit new rubber boots to the rear axles, which involves removing the rear axles and probably the A-frames. And the reason I'm changing the boots is that this one's pretty torn up with a tear there and a tear there. That's one of them. The other one is actually in good condition, so I've ordered just one new one. It hasn't arrived yet, but I can make preparation now to change it. So the first thing I've done is use my car hoist above here to help lift the back of the bike up off the ground. I've placed a couple of stools underneath there. I've removed the wheels and I'm now ready to remove the cotter pins and make preparation to remove the axles themselves. So I'll make a start on that. The brake drum on the right rear will just slide off the studs once you've released the wheel. On the left hand side, this spacer wheel plate just slides off the studs. It basically does the same job as the drum does on this side of just taking up this a little small amount of space to keep the wheels the same. So cotter pin here on both sides and then the big nut. I will undo those. I believe the nut is 30mm. I've got a impact socket that fits that and should run that off pretty easy once I've removed the cotter pin. This drum is not just falling off. There's a little bit of load on the pads, or they're rubbing enough just to stop it pulling away. So I'm going to release the foot brake cable that connects to this arm here. There's a little R-clip down there. Some bikes will have a cotter pin. That's the little R-clip I've just pulled out of that hole, and I will go ahead now and pull that pin out, save the washers, and that's released that lever, and now I suspect that brake drum will come off easily because the pads have now returned to the centre. So I think this possibly had to come off anyway in the process of, well, we'll see. I think the arm's got to drop down to let the axle out, so I'm not sure whether the brake lever had to come off, but it was easy enough to do. So okay, this is the 30mm nut. I've taken the cotter pin out using this little Makita impact to spin that nut off. As this has all been apart fairly recently, I'm not sort of expecting too many frozen parts on it. So, well, looking at it, maybe that drum did not need to come off, but in your case, it's good to have a look at the brake. You're that close to looking at it. Now, thinking about the process here to get the axle out, I think I need to release the pivot point here for the swing arm, the shock absorber here, and the pivot point similar to this one at the front end of that swing arm. And that swing arm should then swing, well, pull out of the chassis in this direction, creating enough space for the axle to push back through the hub there and come away. I'm going to try doing that with all of the tubes and cables still attached to the swing arm. If that doesn't work, I'll need to release those as well, but we'll have a go. I decided I needed to remove the rear brake cable, undid the 2 bolts that hold this little bracket in. I'd already removed the R-clip to remove that clip, and then removed that from the, pull it out past this wire here that retained it. There's also a breather pipe that goes down through that wire that plugs onto the back of the brake drum there. It normally feeds through that wire there as well. So both those are out of the way, so there's no connections now to the brake drum that will hang it up. I've removed the bolt through the front here, and I've removed the bolt through the back there. It's just sort of hanging in place at the moment. I've got the bolt for the shock absorber mostly removed. All the weight's probably on it at the moment. If I pull that out, I think that whole swing arm is now free to drop away, and the axle will separate from the U-joint, the top inner U-joint, by pulling out at this end here, which will let that whole swing arm come away in my hands. It won't need to pull out of here at this point. I do want to remove the whole axle and the top U-joint because I want to install it all in one piece to make sure it's got the right phase for the uni joints, and at that stage it will have the boots on it as well. So that's what I'm going to do next. I'll pull that whole swing arm out. Well, that's come away. This top bracket seemed to hang up a little bit in the clevis there. Bottom one came out without any problem. And here, top of the shock absorber. The axle pulled out of this inner U-joint, and you'd think, well, that's all I need to do to put a boot on there. But I want to actually remove this and the axle completely from the hub, because I want to make sure I've got both the U-joints timed, phased correctly. And I think the only way to be sure of that is to put the 2 pieces, pull the 2 pieces out, and make sure they're perfectly aligned, phased correctly with the boot on, to before, and install it as one piece when I put it back together. So that's what I'm going to do. The next step from this side is I want to remove this top U-joint, and that can be difficult, and it can be, sometimes they come easy enough. So what I suspect, I was having trouble phasing these when I assembled it recently, and I'm wondering whether there's effectively a left and a right side of these, because I couldn't get the phasing right. In fact, I set it up in the end 90 degrees out of phase, which I'm told is wrong, and but that was the only position where I could get, well, I couldn't get it to line up perfectly at 0 degrees, but I could get it to line up perfectly at 90 degrees. And I'm just wondering whether that's a difference between left and right. Effectively, the closest I could get to 0 degrees was effectively a partial spline away from 0 degrees, perhaps half a spline effectively. So that's what I wanted to investigate fully this time. I assumed, because I couldn't get it on 0 degrees, that getting it at 90 degrees was going to be fine. But I see from a lot of diagrams that having them at 90 degrees is incorrect. So we'll push on and see what I can do. I'm going to take both of these out and both axles out and try and set them up on the bench. I've removed the inner U-joint. It popped off fairly easily. I used a screwdriver in the gap through here and a little lever like that on the top there, and a little bit of wiggling, and the U-joint popped right out of there. The easiest that I've done it ever. So let's hope the other side comes off as easy. I'm going to now do everything the same to the other side. I'll remove the A-arm. I don't have any control tubes or anything to remove, so it should be a little bit easier. Okay, that's both sides released. I had a little bit more trouble levering the inner uni joint off on this side, but not much. Still just use the same method of screwdrivers in behind it. The swing arm came off a little bit easier, and I've knocked the outer U-joint axle out of the swing arm in this case already. I want to see how I go pairing them up now in phase, so I don't lose that phase alignment, and that may involve swapping the upper U-joints around, because I was having issues when I put it together last time. Last time I had the upper U-joints in place and was trying to fit the outer U-joint axle to the upper U-joint while it was in place, and it didn't seem to be giving me the phasing that I wanted, and I think I ended up setting them up exactly 90 degrees out of phase, thinking that would be the same. Anything in between 0 and 90 degrees I know is definitely wrong, but I thought 0 or 90 degrees didn't matter, but maybe I'm wrong with that. I haven't still been able to confirm that, but I couldn't set them up at 0. They always seem to be about maybe half a spline out of 0 alignment, so I'm wondering whether that's something to do with the pairing of the upper and lower shafts that can be fixed if I swap the uppers around. So I'll do that once I've cleaned the parts up. I wanted to talk about phasing of these drive shafts. The universal joints, the correct way to phase them is to have, you can see that clevis and that clevis lined up with each other, and that's a matter of selecting the correct spline on here so that they're lined up. Now, in a normal circumstances, when that one is sitting flat on the ground there, this one should be sitting flat on the ground. And now I can get a little bit of rock in this end just a little bit like that in this case. When this one's sitting flat, this one wants to rock, as you can see, a small amount. Now that's not much, and it's probably quite acceptable. This one, on the other hand, when this is sitting flat on the ground, this end wants to rock that much. And it's a 22 spline shaft here. So 360 degrees divided by 22 means that each spline is the equivalent of 16.3 degrees of variation. Now where this is rocking that much, which I think is significant, if I move it to the next spline, it rocks slightly more, only slightly more. And I've done a bit of a calculation, and if that's 16 degrees variation between the splines, I believe we've got maybe a split 7 degrees versus 9 degrees on the two, choosing the different splines there. And this is the least rock it has. If I moved it to the next spline, it would have a little bit more, about 9 degrees movement. So I've done that. I've done that calculation because this has bothered me a bit. When uni drive shafts like this should have virtually no misalignment like that. Both of these shafts have some. I've watched videos talking about Toyota propeller shafts in cars, and they talk about anything more than 3 degrees variation is unacceptable. But given in a car, a propeller shaft can be doing 4,000 revs, and if it's got that out of phase component running at 4,000 revs, it can cause problems. Now, being out of phase, what does that mean? Well, you probably need to watch some of the videos yourself about phasing propeller shafts or drive shafts. If this end and that end are aligned, the actual intermediate shaft can be at an angle, but it's the angle taken up here and the angle taken up here, if it's the same, if you've got an input shaft like this and an output shaft like that, this runs at a constant velocity and that will run at a constant velocity if the U-joints are phased correctly. If they're not phased correctly, you get the intermediate shaft, if it's on an angle, it actually sort of has an elliptical sort of speed variation, and that transfers to the output. The input constant velocity, elliptical sort of speed is translated back to constant velocity if the angles in and the angles out are the same. Now on these quad bikes, if you've got your preload set on the shock absorbers and the wheels are sitting quite vertical, the shaft in the motor is vertical and the shaft going to the wheel, well, let's say it's horizontal. The shaft in the motor is horizontal, the shaft going to the wheel's horizontal if the wheel's sitting nice and vertical, and therefore the uni joints do the job correctly. If you've got the preload on the shock absorbers set too low and the wheel on the outside here is cocked out like this because the back of the bike's got a sag on it and you've got too much load on it, then the input shaft and the output shaft aren't parallel, and you can get a wobble. Now that wobble or variation in speed is further affected by the phasing of these joints. I'm just a little bit disappointed that as in standard form I can't line that up. Now is that because it's a mismatch of a replacement axle? I actually think these axles have been replaced as one. The paint on them is very similar all the way through. Maybe they've actually twisted a fraction. That's also a possibility. But anyway, I'm going to put it together. That's that's the best in phase that I can get. To be honest with you, when I first assembled this bike, I thought that this end being 90 degrees out of phase didn't make any difference. I thought that being 45 degrees out of phase was the biggest problem, but 90 degrees was fine. But after watching videos, 90 degrees is the worst location for the phase to be out. That means this end is facing that way and that one's facing at 90 degrees. That's the worst scenario for out of phase uni joints. Now, I've run this bike for a couple of outings with the joints in the worst location. This is a far better situation, and given that these shafts don't work in the ideal situation where the input and the output is always parallel with each other, then a small amount of phase difference like I've got here is not going to be as big a problem as I perhaps initially thought, and I'm just going to go ahead and assemble it like it is. So that's a bit of a lecture on phasing drive shafts. I hope you've understood that, and I'm going to go ahead and assemble them now. I've got one new U-joint boot. It's come in the post yesterday. That cost about the same as trying to buy a universal boot at the local auto parts store, so that's a reasonable price, genuine Suzuki part. I've only bought one because I've got a second one that hasn't got a tear in it, and I'm going to continue to use it. So that's in Australian dollars, it was just around $20, $19.10 there for the boot. Interesting, it costs another $20 to get it freighted here, but that's good to have an original part. I could have bought two of them and total price would have been $60, but at the moment I don't think I need the second one, and I've worked out they're pretty easy to change anyway. I've fitted these boots and put a clip on to hold them on. Getting those boots to come up, particularly the new one, over the cover here was difficult. I just had to persevere with it. I've put this clip on. See, the tail end of it points towards what I'd call the rear there, and on the same here, the clip points to the tail end points towards the rear. You can imagine those axles rotating, the bike rolling towards me in this direction, and so those clips won't pick up any crap or catch on things while they're rotating towards me, and so they're effectively on in opposite directions to each other, making this one the left-hand rear axle and this one the right-hand rear axle. So that's really the only thing that dictates. So the older boot I've fitted to the right-hand side, newer boot on the left-hand side. I'll go and look to fit those up now. I put some grease in each of those boots. I got some grease from a CV kit, boot kit. These boots weren't suitable for the application, but the kit they came in had a packet of grease and these clips included, and they were a sellout at the local auto parts store for 10 cents each. So just the grease and the clip was worth the money, and they're not far off the size. The hole in that size end is correct for the axle, and the hole in this end is about right for this flange, but the flange isn't long enough to work with those. I bought 6 of them, so it cost me a total of 60 cents, and I may well muck around making longer flanges. My 1990 bike has got the older style axles and no covers over the U-joint. I'm hoping to make these ones fit after I finish up on this job, and I've got grease and clips from the other 4 of them to try and make something work. So I'm pretty happy with this. I'm going back to reinstalling them now. So I'm just fitting this axle back in. Lighting under here is not great. Just using the screwdriver there to prop up the axle. You can see this pivot point isn't located, and neither is the lower one there at the moment. I've got the axle poked through the outer hub here and a nut on it just to hold it in place, keep it pulled in this direction. So the next job is to bump these into the position and put their respective bolts through, and put the shocker bolt through. So there's the boots attached there now. Last thing I've got to do is connect the handbrake cable to this lever, and we're done. Put the wheels back on. So that was a successful project, and it will keep the water out of those uni joints. It's those uni joints that do all the work really. That's where most of the bend happens. The lower or outer U-joints are lesser of an angle, and certainly not exposed to the dirt as much, being up inside those tubes. There's it's that upper U-joint that does all the work, and it's good to see them covered up. And I think I'll work to do a similar thing on my 1990 bike with those cheap boots I got. So I'll put the wheels on and lower it down. So it's all done, wheels are on. I hadn't attached the tow bar. Need to find a ball for it as well somewhere, but while it was up in the bum in the air like this, it was a handy time to put that tow bar on. So there's the new rubbers in there, wheels are on. She all looks good. So it's time to lower this down. It's I'll lower it down onto those stools by just lowering my hoist down, and then from the stools lower it down a bit further.
The grandkids makes playing with these things all the more worthwhile. Get out to your shed and have some fun.